The third form of a quadratic that we're going to look at is called intercept form. So this, you can tell, looks like if you take a quadratic and factor it. We get these two sets of parentheses, and indeed if we were to FOIL this, you would get a quadratic. So first times first is x squared, and then you get some other stuff. But the point here is it has an x squared, so that makes it a quadratic. That makes it this parabola shape. All right, again, if you don't know how to graph something, just throw some numbers into the equation and see what happens. So let's do just that. We'll make a table, throw in some random values and see what happens. Now again, the values I'm going to choose here aren't totally random, but again, I'll tell you how to choose good values in this lesson, so just hang on for that. So we'll start with just 0 up through, say, 8. All right, so if we plug in 0 then, we're going to get y equals 0 minus 2 times 0 minus 6. Well, that's negative 2 times negative 6 is positive 12. If we plug in 1, we get 1 minus 2 in the first set of parentheses, 1 minus 6 in the second set of parentheses. 1 minus 2 is negative 1, and 1 minus 6 is negative 5. Negative 1 times negative 5 is positive 5. Now let's see what happens if we plug in 2. All right, so we get 2 minus 2 in the second set of parentheses, and 2 minus 6 in the second set of parentheses. Well, 2 minus 2 is 0. 2 minus 6 is negative 4. Well, look at this. We've got a 0 in there. Anything times 0 is 0, so we're going to get 0. Well, hey, that's kind of nice. So if we plug in 2, because this set of parentheses is x minus 2, so if we plug in an x value of 2, we get 0. That's kind of nice, and then we multiply by 0 and we get 0. Well, let's think about how else we could get a 0 in there. Well, the other set of parentheses is x minus 6, so what happens if we plug in 6 then? So we get 6 minus 2 and then 6 minus 6. Well, in the first set of parentheses, that's 4. And in the second set of parentheses, 6 minus 6 is 0. Hey, we get 0 again. That's kind of nice. So we can plug in 0 there. Well, then we'd want to go through and find the y values for all of those other x values. And if you plug all those in and then graph the points, this is the quadratic that you get. This is the parabola that you get. So you'll notice, or hopefully you'll notice, these two numbers here, very important numbers, 2 and 6. Well, that 2 and 6, they're in the equation there. Again, that is not a coincidence. So because when we plugged in 2 for x, we got 2 minus 2, which is 0, and then we multiply that by something. It doesn't matter what we multiply that by, because anything times 0 is 0. So we get this 0 right here, which is this point right here. Similarly, when we plug in 6, that makes this one 0, which gives us this one right here, which is this point right here. And so this one's called intercept form, because just by looking at the graph, you can tell what the x-intercepts of the parabola are. So the 2 and 6 are the x-intercepts. Well, if we want to know where the axis of symmetry is, well, that's the vertex of the parabola. So in this case, you can tell it's going to be this line right here. You can tell that just by looking at the graph. But we can get that a different way. So remember that parabolas have symmetry. So that means that for this point right here, the x value 2 and the x value 6, those two are the intercepts, and they're symmetric. And so if we want to know the axis of symmetry, that's the point that is exactly halfway between those. Well, how do we find the halfway point between 2 points? We average them. And so from intercept form, if you want to know where the axis of symmetry is, you can just average the two x-intercepts. So we do 2 plus 6 divided by 2. That's going to be 8 divided by 2, which is 4. And you can tell that is exactly where I just drew that line from looking at it. So again, for this one, you can tell fairly easily just by looking at the graph where the axis of symmetry is, but it won't always be super easy to find exactly where it is. So averaging the two x-intercepts is a good way to find that. And then for the y-intercept, Well, looking at the equation for this one, there's no good way to find the y-intercept, but again, you can always find the y-intercept just by plugging in 0 for x, and then see what you get. So in this case, that's 12, which is this point up here, or this coordinate point right here. Let's do another one of these. So let's first answer the questions here without graphing it, and then let's look at graphing it. So will the parabola open up or down? Well, again, that's going to be determined by the number out front. That's a -2, which is going to make this parabola open downwards. Also, that 2 is going to stretch the parabola out a bit. What are the x-intercepts? Well, again, we want to think about for x-intercepts, how do we make what's in these parentheses 0? So for the first set of parentheses, x plus 3, well, how do we make that 0? Well, we plug in -3. So if we plug in -3, then we're going to get -2 times, then in parentheses, -3 plus 3, -3 minus 1. And so we get -2 times, that -3 plus 3 is 0, and then times -4. Well, we've got a couple things times 0 there, but anything times 0 is 0, so that's going to mean we get 0. So if we plug in -3, we get the point 0. Now I said we were going to do this without graphing, but let me just plot that on the graph real quick. And we could do the exact same thing with the other set of parentheses. So if we want to figure out how to make the second set of parentheses 0, well, what we would do for that is we would plug in 1 for x, because 1 minus 1 is 0. And then we'd get 1 plus 3 over here, and times -2. Well, all this stuff over here doesn't matter. The important bit is we have 1 minus 1, which is 0. So we have 0 times something. Doesn't matter what that thing is. That's going to give us 0. So here we plugged in 1 for x, and then we got 0 for y. So that's going to be this point right here. So again, those are the x-intercepts. So that's why this is called intercept form, because looking at the graph, we can find the two x-intercepts just by looking at that graph, figuring out what you need to plug in to make that 0. All right, so the x-intercepts then are -3 and 1. Well, the axis of symmetry, that again is the average of the two x-intercepts. So if we average those two numbers, -3 plus 1 divided by 2, that's going to be -2 over 2, which is -1. And we'll plot that on the graph as well. Where's the vertex? Well, remember the vertex is on that axis of symmetry. So if we want to find where the vertex is, we can just plug in the x value that we found from the axis of symmetry, which is -1. So let's plug that in. So we get -2 times the -1 plus 3, and -1 minus 1. -1 plus 3 is 2, -1 minus 1 is -2. So we get 2 times 2 times, -2 times 2 times -2. That's going to be +8. So the vertex is at the coordinate point -1, 8. So we plugged in -1 for x, and we got 8. And you can see then, of course, this lies on that axis of symmetry. So then to graph the function, well, we've got 3 points. That's enough to graph a parabola.